Hey guys, this video is all about the Pythagorean theorem. So even though we're actually in chapter 8 right now, this stuff is actually from section 5.7 in your book. But regardless, it's all about the Pythagorean theorem, which you guys have probably heard of before. It is actually called Geometry's Most Elegant Theorem. It's pretty cool. We use it for a lot of good stuff. But the theorem states that in a right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Okay, that is a lot of words, right? So we have to think about what we know about right triangles. So in a right triangle, we know that the longest side is the hypotenuse. So I'm going to go ahead and label that hyp. We know that's our hypotenuse. It's across from the right angle, right? And the two sides that make up the right angle, those are the legs. All right, so A is a leg and B is a leg. So this theorem says that the sum of the squares of the lengths of the legs, well, that really just is a fancy way of saying A squared plus B squared, right? A is a leg, so square it. B is a leg, so square it. Sum means we're adding them together, and that is going to equal the square of the hypotenuse. So it's going to equal c squared. You guys have probably even already seen this, but putting it into those words is a little weird. Okay, but that's all it means. We are going to talk a little bit about Pythagorean triples. So a Pythagorean triple is a set of three non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared. And that is what we call a Pythagorean triple. Okay, because we know we can take three different numbers and add them together, right? Or, I'm sorry, two different numbers, take the squares of them and add them together and get to a third one. Well, a Pythagorean triple is a special set of numbers such that it always works with a squared plus b squared equals c squared. So a common one is a 3, 4, 5 triangle, or a 5, 12, 13. 8, 15, 17 is a common one that we might see. And 7, 24, 25 is another one that's pretty common. So those sets of numbers are always going to make right triangles. And the cool thing about it is the ratios of those are always going to be the same too. So for example, if I took a 3, 4, 5 triangle, if I multiply each of those by 2, I get 6, 8, and 10. That is also a right triangle. Okay, because we just learned about special right triangles, right? If their sides are proportional, so for example, if I double all of them, then it's going to be a similar triangle, which means it's also going to be a right triangle. Okay, so we're going to deal a lot with that kind of stuff this chapter. Moving on, we have the converse of the Pythagorean theorem. All right, so Pythagorean theorem says, hey, a squared plus b squared equals c squared anytime we have a right triangle, right? So the converse is the opposite. It's if the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So in order to use Pythagorean theorem, we have to have a right triangle. So this is the opposite. This is saying, hey, if Pythagorean theorem is true, then you have a right triangle. All right, so our hypothesis here is that a squared plus b squared equals c squared. So that's if this is true. Then our conclusion is that triangle ABC is a right triangle. And in fact, since they're saying that it's equal to c squared, that means we must be able to say that angle C is a right angle, because that's across from the hypotenuse. Okay? These Pythagorean inequalities theorems, it's not as bad as it looks, okay? In triangle ABC, C is always the longest side. Okay? So we are always going to refer to C as the longest side. If C squared is greater than a squared plus b squared, then the triangle is actually obtuse. Okay? And if it is less than a squared plus b squared, it's acute. We know that if it's equal to, Pythagorean theorem says if c squared is equal to a squared plus b squared, then triangle ABC is right. That's technically what Pythagorean theorem says, right? So those are our three options. Either c squared is greater than a squared plus b squared, and we get obtuse. C squared is less than a squared plus b squared, and we get acute. Or c squared is equal to a squared plus b squared, and we get a right triangle, okay? I always tend to put c squared first because if it's greater than, it's obtuse, and obtuse is the bigger angles, right? And then less than would be acute, so it kind of helps me remember like which one is which. So that usually is kind of a good thing to remember, okay? So let's see what some of this looks like. So section 5.7, again, Pythagorean theorem. There's your learning targets up on the top. You've got them in your packet. You can take a look. Okay, hopefully you guys all have the calculator that I gave you at the beginning of the year, which is this TI-30XS, because if you do, these problems are going to be super easy for you and you don't have to do any work other than put it in your calculator. Alright, first things first, make sure that you are in math print mode. So if you notice I hit the mode button and math print is the one that is highlighted right now, so that's good. If it wasn't, I would just have to go down and hit enter on it. Okay, I want to put in the square root of 200. I want to simplify this, okay? I want it in simplest radical form. I do not want a decimal. Write yourself a note. No decimals here. Okay, unless I ask you to round, you are going to be giving things to me in simplest radical form. All right, so the square root of 200, watch how easy this is. Square root 200, bam, it's 10 root 2. And that's it. If you've got this calculator or a calculator that will simplify it for you, you don't have to show me any work for this. Your calculator will do it. Now here's the tricky part. If you don't have this calculator, you have to do this by hand. Okay, so we are going to make a factor tree, and I hope that this is something you guys remember from Algebra 1. But we're going to take the number 200, because that is my radicand, that's what's inside my radical. And I'm going to start breaking it up into its prime numbers. Well, I know that 200 is the same as 2 times 100. 100 is 2 times 50. 50 is 2 times 25. And 25 is 5 times 5. Okay, so those are all of my prime numbers for 200. Remember, prime means that it's only divisible by 1 and itself. So I've got some 2's and some 5's. So I can write this as, there's 3 2's, so 1, 2, 3. And then there's 2 5's also. Since it's a square root, it means I need pairs in order to take them out. So I have a pair of 2's that are going to come out, and I have a pair of 5's that are going to come out. So I have a 2 times 5 on the outside, and then I am left with this single 2 on the inside, and then we can just multiply. 2 times 5 is 10, so I get 10 red 2. I get to the same answer, okay, but my calculator gives it to me right away, so that's nice. If you can notice that 10 squared is 100 and you can simplify it from here, that's awesome too. If you notice that 200 is the same as 2 times 100 and you can simplify the radical that way, that's cool, because 100 can pop out and turn into a 10. Alright, if you need more help with that, just call me over in class tomorrow. We can take a look at it. Okay, but then why don't you guys give it a shot? Alright, put the square root of 100 into your calculator. And if you need to do it by hand, do it by hand. But I want it in simplest radical form. What is the square root of 180? So square root, remember that button is right here. You have to hit second, and then the x squared button, and 180. And we get 6 red 5. Okay, and that's going to be important because, again, no decimals for this chapter unless I ask you to round. But most of the time I'm going to ask for simplest radical form. Alright, so find the value of the variable in simplest radical form. Determine whether the sides form a Pythagorean triple. So again, we're looking for, are all of the sides whole numbers? Okay, that's what I mean by Pythagorean triple. So when we look here, here's my right angle, and across from that is my C value. That's my hypotenuse. Okay, and then the other two sides, it doesn't matter which one is A and which one is B. Just go ahead and throw an A and a B. So if I were you, I would suggest writing a squared plus b squared equals c squared first, and then plug in what you know. So we've got 6 squared plus 8 squared equals x squared, and we are going to solve for x. So we've got 36 plus 64 equals x squared. So 100 equals x squared. And then in order to get rid of something squared, we have to take the square root. So we get x equals 10. Okay? If you need to plug it in your calculator, by the way, if you're not good with your perfect squares, 6 to the power of 2, that's where the 36 comes from, and same thing with 64. Okay? And you can do the square root of 100 on your calculator if you need to, but you should know at least some of those numbers by heart. Okay, so we've got sides that are 6, 8, and 10. Those are all whole numbers, so yes, this is a Pythagorean triple. And you can just write the 3 sides are whole numbers. Okay, we do want just a little bit of an explanation there so that I know you understand what it means to be a Pythagorean triple. Okay? Taking a look at number 5 then, hopefully you can identify the hypotenuse right away. Here's our right angle, which means across from that is our hypotenuse. That's our 13. Okay, so I'm going to put a C right there. And again, a squared plus b squared equals c squared. Here's where this is going to be important. Okay, well, one of the places that this is going to be important. Don't get 37, the square root of 37, as a decimal. Leave it as the square root of 37, okay? Trust me on this, because x squared plus the square root of 37 squared equals 13 squared. If I put a decimal in there, it means that I'm going to round it, and then that means that this is going to get rounded, and that's going to be a disaster. So watch what happens. Square root of 37, and then I square it. Hopefully you can even tell me what's going to happen. The radical cancels. Okay, so it's 37. X squared plus 37 equals 169. Okay, 13 squared. So then x squared is 132. And then we want to take the square root of that. So the square root of 132. And our calculator simplifies it for us, which is really awesome, to root 33. Again, if you don't have this calculator, you're going to have to do that by hand, because leaving it as the square root of 132 is not acceptable, and turning it into a decimal is not acceptable. Okay, the answer I'm looking for is 2 rad 33. In terms of Pythagorean triple, this one is not, because the square root of 37 and 2 rad 33 are not whole numbers. Okay, Pythagorean triples mean that they're whole numbers. Cool? Moving right along, let's jump to number 7. Okay, we're still finding the value in simplest radical form and determining whether the sides are Pythagorean triple or not. But these ones are a little bit trickier. Okay, again, here's my right angle, and the side across from that is my hypotenuse. So that means this is my C value. Okay, and again, I'm going to label one side as A and one side as B. It doesn't matter which one is which. Okay, but now we've got A squared plus B squared equals C squared. And on a problem like this, you guys, parentheses are going to be so important. Okay, so for my A, it's x minus 1 squared plus my B, which is 5 squared, equals my hypotenuse, which is x squared. Okay, again, notice it's x minus 1 squared. Okay, and remember, anytime you have something squared, it means that times itself, which means this is really saying x minus 1 times x minus 1. Okay, and then 5 squared, you guys can do 25, and then on this side we get the x squared. That's fine. It's this right here that we have to talk about. Okay, you're going to have to double distribute that, okay, or FOIL, however it was that your Algebra 1 teacher taught you. But we're going to take the x and we're going to multiply it to both pieces in the second binomial. So x times x is x squared, and x times negative 1 is negative 1x. And then we're going to take the negative 1 and distribute it to both pieces. So negative 1 times x is another negative 1x, and negative 1 times negative 1 is a positive 1. And then we're just going to bring down the plus 25 equals x squared. Hopefully that looks familiar. If you guys can do that in your head without writing it out, that's totally fine too. This then simplifies to x squared minus 2x. And then I'm going to go ahead and combine these only because I have it written out already. So plus 26 equals x squared. But if you guys can jump from here to here in your head, that's totally fine. If you need to draw this out, that's fine too. And we can talk about it in class if you need a little bit more of a refresher on that. Okay? So then solving this, I've got an x squared on both sides. So I'm going to go ahead and subtract x squared. And when I do that, they both cancel, which means now I have negative 2x plus 26 equals 0. Okay, and now I just need to solve for x. Subtract the 26 from both sides. So negative 2x equals negative 26, and then divide both sides by negative 2, and we get x equals 13. Okay, so let's go back up to our picture here and see what that means then. So x is 13. That means the hypotenuse, this side right here, is 13. Okay, and then this value over here, a, well, that's x minus 1, and we said x is 13, so 13 minus 1, that means this side is 12. So if we look at our triangle, it's a 5, 12, 13. So let's go ahead and fill in x is 13, so we found our answer there. Okay, and they're all whole numbers, so yes, this one is a Pythagorean triple. Okay. Let's go ahead and jump to the next page. We're going to look at number 9. So these questions are asking us to classify the triangle as acute, obtuse, or right. So this is using that those Pythagorean inequality, the Pythagorean inequalities theorem, okay, where we said that it's acute if c squared is less than a squared plus b squared. That's what makes a triangle acute, and it's going to be obtuse if c squared is greater than a squared plus b squared. And then we know that it's a right triangle when c squared equals a squared plus b squared. So in order to do this, we have to identify our c value first, okay? And c is always the longest side. C is the longest side. Okay, so take a look at number 9. All right, the longest side there is 10, so that's going to be our c value. And then again, pick the other ones as a and b. It doesn't really matter. But what I usually do to start this out, I do c squared, and then I put a box. And then it's a squared plus b squared. And I plug in what I know and I simplify until I can figure out what goes in that box. Is it a less than, a greater than, or an equal to? Okay. So c squared is 10 squared, a squared, so that's 4 squared, and then b squared, so that's 8 squared. Okay, I'm going to put my box down again. 10 squared is 100, so I know that. 4 squared is 16, and 8 squared is 64, which means I get 100 on the left side, and I get 80 on the right side. So if I look at that, that means then that 100 is greater than 80, okay? And anytime c squared is greater than the sum of the other two sides, sum of the squares of the other two sides, then it's obtuse. So this triangle was obtuse, okay? I want to see each of those steps when you go through these problems, okay? So please make sure you are including them. Number 10 looks a little different, right? we need to be able to identify the longest side. Well, we've got 11, 16, and 5 root 7. I don't know about you guys, but I don't know what 5 root 7 is off the top of my head, so I don't know if that's longer than 16 or not. So grab your calculators, okay, and I'm going to show you how to do this. So 5 and then the square root of 7. If I hit enter, it just spits it back at me, right? But if you look at the bottom of your calculator, there's these two arrows right here above the enter sign. Hit those two arrows, and when you do, it turns it into a decimal for you. Okay, so 5 rad 7 is roughly 13.2. So it's about 13.2, which means when we look at these sides here, my longest side is 16. That means that's my C value. Okay, so again, set it up C squared, and then I've got my A squared plus B squared. So I've got 16 squared, and then again, the other two, it doesn't really matter. So 11 squared, and then plus, this is really important, ready? I have to have parentheses around this 5 rad 7 squared, okay? Now notice I didn't put the decimal, okay? So I said earlier that not putting it as a decimal is going to be important. It is 5 times the square root of 7. And those parentheses are going to be really important also, because watch this. If I do 5 times the square root of 7, and then I square it like that without parentheses, I get 35. But watch what happens when I put parentheses. 5 and then the square root of 7 squared, I get 175. Two totally different numbers, right? We are squaring that entire side, which means that entire thing has to be in parentheses. We're looking at that 175. Okay, so 16 squared we get 256, 11 squared we get 121, and then 5 rad 7, that's what I just found to be 175. Okay, and we get then 256, and the other side is 296. 256 is less than 296, and anytime c squared is less than a squared plus b squared, we end up getting an acute triangle. Okay. And I know this video is getting a little long, so we are going to save the rest of them for later. I do, however, want you guys to go back and I want you to try on the page before, try number 6. Just number 6, okay? Not any of the other ones. The only one I'm going to be checking for is number 6. We will talk about the rest of them in class. Okay, I will see you guys later. Bye!